Once the execution of the program 2 is done, then the program 1 also get the chance to use the computer resource. Within fraction of second, whatever the event is going to happen, that must be triggered. So it provides quick event. All the systems want to interact and communicate each other. How they are going to communicate? With the help of softwares as well as hardware interconnection. Hello to all, a warm welcome to my new session on software concept, and this is the last session of this chapter. I'm Revati, faculty, Department of Computer Science, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. In my last session, I have discussed the following topics, that is, what is operating system, functions of operating system, and type of operating system. Now tell me, dear student, what is operating system? So here operating system act like a interface between user and computer system. The best example here is, suppose my house doors are locked. Now I want to get into the house. How can I get in? With the help of lock. That means first I need to open the main door. After that I can able to get inside the house. Similarly, if I want to work done by the computer system, I must have operating system in my computer system. So here operating system act like a gateway between user as well as computer system. Then we had discussion regarding functions of operating system. So what are the functions of operating system? We have discussed in my last session of this chapter, that is memory management, process management, device management, file management, security, as well as command prompt. All these are the functions of operating system. Along with that, we have discussed the type of operating system. So what are the type we discussed there? That is single user operating system as well as batch operating system. These are the certain topics I have covered in my previous session of this chapter. But in my today's session, I'm going to deal with the other type of operating system, that is nothing but multi-programming operating system, distributed operating system, network operating system, multi-threaded operating system. Along with that, today's session, we are going to study about functional features of operating system. In that, we are going to study about what is CUI and what is GUI. So these are the certain topic we are going to study in my today's session. At the beginning, we are going to have multi-programming operating system. So here, what is multiprogramming? Multiprogramming is the capacity of CPU to execute more, that is 2 or more programs concurrently. For example, think that I'm going to write a program, that is PRG1. So this program includes 2 or 3 programs. Now consider I'm having subprogram 1, subprogram 2 and subprogram 3 in my main program, that is PRG1. Now this is the capability of the CPU to execute 2 or more programs concurrently. That means, suppose if I want to execute my program, that is program 1, along with subprogram 1, subprogram 2 and subprogram 3 concurrently, that can be achieved with the help of multiprogramming. That means when I call my subprogram in my main program, the control is transferred to subprogram 1. It's going to perform its activity and moves back to the main program. And once again, if I call subprogram 2, execute the subprogram, complete its procedure, then move back to program 1. Now, if I call subprogram 3, execute all its activity, then move back to program 1. This is the way we can able to perform one or more activity or programs concurrently. Now, who is responsible for allocating the resource? There is nothing but the CPU. So here multiprogramming is the capacity or capability of computer to execute two or more programs concurrently. Now, two or more programs are stored concurrently in primary storage. If I consider same example, think that I'm going to have the memory in my computer system, and at the beginning I'm going to store my main program, that is program 1. Under that I'm going to save subprogram 2 and subprogram 3. Now where I'm going to store all these programs? In my primary memory, because dear student, we know that all the files, all the programs are usually stored under secondary storage, and whenever I want to execute that program or files, what I'm going to do? I'm going to get that file which is stored in the secondary memory to primary memory. So in multiprogramming operating system, two or more programs are stored concurrently in primary storage, and the CPU moves from one program to another, partially executing each in turn. So here where I'm going to store the programs? In my primary memory or in my main memory. Now it is the responsibility of the CPU to execute this program, that is program 1, then move to subprogram 1. After the completion of subprogram 1, go back to program 1. From program 1, move to subprogram 2. After the completion of subprogram 2, move back to program 1. Once the execution is done, then move to subprogram 3. Complete its execution. Once the execution is done, go back to program 1. This is the way the multiprogramming is going to work. So in early computer system and many personal computer system executes program in the order in which it is read into the system. So in early days, we are going to use multiprogramming concept, and the job or the program which is present at the first location, it's going to execute first. Then the next job or next program is going to get the chance. So it's going to execute all the instruction in first come, first serve order. Then only one program can execute at a time. But users are going to think that all the programs are executing concurrently. But according to the CPU, only one program can able to execute at a time. So what is multiprogramming here? Here multiprogramming is the capacity or capability of the CPU to execute two or more programs concurrently. Moving further, I'm going to have the another type of operating system. So what it is? It is multitasking. So what is multitasking? I'm going to perform multiple tasks at a time. For example, think that I'm going to write a notes. At the same time, I'm going to listen to the music. So what I'm going to do here, I'm going to perform two activities at a time. So here, if I consider multitasking operating system, here operating systems are capable to perform multiple tasks at a time. So here, multitasking operating system allow more than one program to run at a time. So here I can able to run more than one program at a time. It gives you the precision of two or more tasks running at the same time. How it's possible to run two or more tasks at the same time? Because CPU provides shared resource. By using shared resource, we can execute or we can able to run two or more tasks at a time, because CPU is going to provide the shared resource. So these shared resources are occupied by all the programs or all the tasks. Based on that, we can able to run multiple tasks at a time, dividing system resource among these tasks. For example, think that inside the CPU, we are going to have shared resource. So what is resource here? That's nothing but CPU, input device as well as output device. And all these devices are shared among all the tasks. Itself called multitasking. Let me to take the simple example here. Think that I'm going to prepare a Word document. That's nothing but I'm going to prepare a notes. At the same time, what I'm going to do here is I'm going to listen to the music. So here I'm going to perform two tasks simultaneously, and it is achieved because of shared resource. So here multitasking is usually implemented by code and data of several programs in memory simultaneously and multiplexing processor and IO devices among them. That means to achieve multitasking, I'm going to have code as well as data section. Along with that, I'm going to store all these things in the memory simultaneously, and I'm going to use multiplexing processor along with input devices. So here the multitasking is also called context switching. So what is context switching and what is the need of context switching? For example, that I'm going to prepare a notes by using word processor. At the same time, what I will do, I'm going to listen to the music. Now, the CPU want to switch between these two operations, that is typing notes at the same time listening to the music. That is nothing but called context switching. That means it is going to perform some activities under word processor. At the same time, the CPU is responsible for running music. So, this type of activities are called context switching. That means the job is going to switch between two jobs is called context switching. And multitasking is usually refers to a single user. So here multitasking are carried out by the single user. The best example, think that I'm the single user and I want to prepare a notes for this subject. Along with that, I'm going to listen to the music. So here I'm going to perform two activities parallelly. So here multitasking is refers to a single user. And the best example for multitasking operating system is Windows 98. Moving further, I'm going to have multi-user operating system. So what is multi-user? Here multi means what? Two or more users are going to use same operating system. A multi-user operating system allows multiple users on different computer or terminal to access a single system with one OS. So consider the example here. Here I'm having multi-user operating system and it's going to connect it with n number of users. Now the users are able to access the resources of multi-user operating system. So here what is multi-user? More than two users can able to access the computers or terminals across a single system with one OS. It creates and maintains individual environment, individual authentication and individual security privileges, provides per user resource usage accounting. So what is the advantage of multi-user operating system? It's going to maintain individual environment and individual authentication. Along with that security privilege, along with that it provides per usage resource usage account. So what is multi-user operating system? The same operating system is used by the multiple user. So that is multiple users on different computer. Okay, so here I'm having user 1 and I'm having user 2. Now I'm going to consider these users are nothing but the terminals and they're going to access a single system with one operating system. Now here I'm having the another type of operating system, that is time sharing operating system. So what is time sharing operating system? Here the name itself indicates that the times are shared between all the programs. So here time sharing operating system allows many users to share the computer resource simultaneously. For example, think that I'm having program 1 and program 2. Okay, now both the program 1 and program 2 requires some computer resource like CPU, input device as well as output device. Now I want to allocate resource for both the programs, program 1 and program 2. That can be achieved with the help of time sharing operating system. That means the program 1 can able to use all the computer resources for certain time slice. After that, the program 2 is going to get the chance. Now the program 2 can able to use all the computer resource for certain time slice. Once the execution of the program 2 is done, then the program 1 also get the chance to use the computer resource. So here time sharing operating system allows many user or many program to share the computer resources simultaneously. So what is simultaneously? That is nothing but parallelly. The time sharing refers to the allocation of computer resource based on time slot. There is nothing but time slice to several programs simultaneously. That means in time sharing, we are going to get the resource based on the time slot. The best example here is computer aided design and text processing system uses time sharing operating system. Moving further, I'm having the diagram here. So this diagram gives the complete information about time sharing operating system. So here I'm having user 1, user 2, user 3, user 4, user 5 and user 6. And all these users want to use CPU resource. Now at the beginning, the first user is going to get the chance to use CPU for some time slot. After that, the user 2 is going to get the chance to use CPU for some time slot. After that, the user 3 is going to get the CPU, that is resource, for some specific time slot, and 4, 5, 6 likewise it is going to continue. So it is in round fashion, that is itself called round robin. So most of the time sharing operating system adopts time slicing. So what is time slicing here? That is nothing but time slot. For particular job, CPU is going to assign the time limit. For example, 3 seconds. Consider the example here. Okay, the user 1 is going to complete its work and time required to complete its work 10 minutes or 10 seconds. I'll take 10 seconds. Now, if I consider program 2 to complete its execution, it requires 5 seconds, and program 3, that is user 3, requires 7 seconds. But according to the CPU time slice, for each user is going to get only 3 seconds at a time. So at the beginning, user 1 is going to get the chance and he or she is going to execute his or her program only for 3 seconds. That is 10 minus 3. What is the remaining times? It is 7 seconds. Then the user 2 is going to get the chance. Execute the program only for 3 seconds. So the remaining timing here is 2 seconds. Then user 3 is going to get the chance, execute the program for 3 seconds. So here 4 seconds are remaining. Once again, user 1 is going to get the chance. So 3 minus 7, it is 4 seconds. Now the user 2 is going to get the chance to complete his or her job. Now the user 2 is going to complete her or his job. Now user 3 is going to get the chance. Now 4 minus 3, only 1 second is remaining. Now user 1 is going to get the chance. After the completion of her job, user 3 is going to get the chance. This is the way the round robin scheduling algorithm is going to work. And each processor or each process will receive a portion of time slot. So whatever the time slot we are going to have, and that will be receive a portion of each time slot. That means each process is going to get the time slice or time slot. The best example here is Unix Windows Server as the example for multi-programming, multi-use and time sharing. So if I use Windows Server as well as Linux or Unix operating system, these are the example for multi-programming, multi-use as well as time sharing operating system. Moving further, we are going to have another type of operating system, that is real-time operating system. So what is real-time operating system? Whatever the event we are going to face in our real time, that must be affected. So I'm going to get the real environment. For example, Real-time system refers to a computer and software system that responds to events before the events become absolute. So, if I use real-time system, that is going to refer to the computer system as well as software system, and it's going to respond to the event before it's going to die, or before it is going to idle, or before it is going to absolute. For example, think that I want to travel from Mysuru to Bangalore. So what I will do, I'm going to visit website to book my ticket. Think that I'm going to travel through bus. So what I will do, I'm going to book the ticket. First, what I will do, I'm going to visit the website. There, I'm going to check the seating capacity and seating allotment. Then, if the seats are free, then I'm going to book the seat. And whatever seat I'm going to book, that must be reflected in that software. That is itself called real-time software or real-time operating system. So, the primary objective of real-time system is to provide quick event. Within fraction of second, whatever the event it's going to happen, that must be triggered. So, it provides quick event and it's going to provide quick response. So, here what's the quick event here? I'm going to allot or reserve the seat and I'm going to do the payment. What response I'm going to get here? The seats are reserved for me. So here I'm going to get quick event along with response times and thus meeting the scheduling deadline. Dear students, let's see the applications of real-time operating system. It is most commonly used in the fields like industrial control system, flight control system, as well as military application. That means whenever I required quick event along with quick response, in that time I'm going to use real-time operating system. That is especially flight control, we required real-time operating system, as well as military applications, we required real-time operating system. And some of the examples here is Windows CE, Linux operating system are the example for real-time operating system. Moving further, I'm going to have another type of operating system, that is distributed operating system. So what is distributed operating system here? A distributed operating system is a collection of autonomous computer system. So what is autonomous computer system here? That is single or separate computer system, and they are capable to communicate and cooperation via the software as well as hardware interconnection. So in distributed operating system, I'm having collection of autonomous system. Now these all the systems want to interact and communicate each other. How they are going to communicate? With the help of softwares as well as hardware interconnection. For example, think that I'm going to have the distributed operating system. Now I'm having user 1, user 2 and user 3. These are the autonomous computer system. And now all these users want to interact with the computer system as well as the user. That can be done with the help of software as well as hardware interconnection. The best example here is ATM centers. So here the best example for distributed operating system is ATM centers. For example, think that I'm going to hold bank account in Jayalakshmipuram. Dear students, think that I'm holding bank account in Jayalakshmipuram branch. Now think that I'm going to draw some amount in some other branch or in some other ATM. Okay, and whatever the amount I'm going to draw, that must be reflected in the bank branch. That is done by using distributed operating system. So how they are going to interact with the software as well as the hardware interconnection, and the best example here is ATM center. Moving further, I'm going to have the network operating system. So I'm going to use the operating system in the network field. So what is network? Why I require network? Suppose if I want to interconnect with the computer system to communicate as well as to share the resources, I require network. So here a network operating system is a collection of software and associated protocols. So what is protocol here? That is nothing but the rules. So a computer network operating system is a collection of software. Along with that, it's going to include the set of rules that allows a set of autonomous computer. For example, think that here I'm going to have the server, or that is nothing but the network operating system, and I'm having user 1, user 2 and user n, and all these systems are connected to the server. And how they are going to connect? With the help of softwares as well as by using associated rules that allows a set of autonomous computer which are interconnected by the computer network, and all these users as well as servers are interconnected via the network. So what is network and why I require network? In here, network is nothing but the interconnection of the computer system. And why I require network here? To communicate as well as to share the resource among all the user. It can be used in a convenient and cost-effective manner. So here all the network operating systems are used in convenient. That means according to the user convenient, we can able to use network operating system as well as it is cost effective. In a network operating system, the users are aware of the existence of multiple computers. So in network operating system, the users are aware of multiple users are existing and they are not bothered about the resources. That means they are going to get all the resources through the network. So they are going to use remote machines. That is, and can log into the remote machine. If I consider server as well as client, I'm going to treat this server as my remote server, and these clients or users are nothing but the clients. And how they are going to interact with the remote server? That is only through the network connection. So in a network operating system, the users are aware of the existence of multiple computers and can log in to a remote machine and copy file from one machine to another machine. Now, the clients are able to log into the server or remote machine, then they can able to copy the files or copy the content to their machine that can be achieved with the help of network operating system. The example for network operating systems are Windows NT, Windows Server and Linux are the example for Windows operating system. Moving further, we are going to have the last type of operating system, that is nothing but the multi-threaded operating system. So what is thread? Here threads are nothing but the light-weighted process, and when I'm having more than one process, then it is called multi-thread. So what is process here? There is nothing but the program in execution. So here a thread is a sequence of instruction within a program. If I consider simple program P1 and it's going to have 3 lines, then each individual lines are treated as single thread. And I'm having here 3 lines, that's nothing but 3 threads. So here 3 threads are nothing but the multi-thread. In my program, if I'm having only one line, then it is single thread. But what is thread here? It is nothing but the sequence of instruction within a program. Okay, sequence means what? One by one instruction. A program or process may have many threads. Okay, if I consider any program or process, they can able to have n number of threads, and they are going to share the common, that is same code section as well as data section. For example, think that I'm going to have the shared resource in my CPU. Now, if I consider thread, here I'm going to have the code section as well as data section, and all the threads are going to use common data section as well as common code section and other operating system resource, and it provides many logical paths through the program to be executed simultaneously. So to execute all the threads, it is going to provide many logical paths. This is the example here. Think that I'm going to have the program 1. There's nothing but process. Now this program includes 4 lines. So here thread 1, thread 2, thread 3, thread 4 are nothing but the 4 lines. So here what is thread? It is nothing but the sequence of instruction within a program. Then the best example for multi-thread operating systems are Sun Solaris, Windows 2000, multi-threaded, Unix, Linux, etc. So these are the example for multi-threaded operating system. So dear student, the type of operating system is very important from the examination point of view. And the last topic under this chapter is functional features of operating system. We know what is operating system. Along with that, we know the features of operating system along with the types of operating system. Then what is the functional features of operating system here? That is nothing but the command line user interface as well as graphical user interface. These are the functional features of operating system. Let's see these features one by one. So at the beginning, I'm going to have CUI. So what is CUI? That is nothing but command user interface. So what is commands here? Suppose if I want to interact with the computer system, I must want to remember the commands. Through the commands, I'm going to interact with the computer system. So, CUI interface allows the user to interact with a computer to text terminal. So, here the CUI is non-graphical and text-based user interface. That means it does not provide any graphical interface to the user, and if the user want to interact with the computer system, then they are going to have the text terminal. There they are going to type the commands. The best example here is Microsoft desktop operating system. The best example here is Microsoft desktop operating system is the best example for command user interface. The commands must be given at the command prompt. Usually we are going to get the command prompt, then here itself user is going to enter the commands. So here if I consider Windows operating system, if I go to the startup, okay, there itself we are going to get one search button. And if I type CMD, there is nothing but the command prompt. So here I'm going to get one pop-up window. That is nothing but the desktop operating system. Okay. Now this is the terminal, or this is called text terminal. There itself I'm going to get the prompt, that is C:// Okay, there I can able to enter the commands. For example, think that I want to create a directory. For that, I want to remember the command, that is mkdir, that is make directory. Once the directory is created, now I want to change the directory. So for that, once again, I need to remember another command, that is cd. Okay, after that, think that I want to move back to the original file or original directory. For that, what I want to do, I'm going to type cd ... That means move back. Think that if I want to remove the directory, for that I'm going to have remove directory. That is RMDIR. So, if I want to work with command user interface, then the user want to remember all the commands. Then user want to type the command. So it is little bit risky. So the command prompt must be given at the command prompt. That means I'm going to give the command in the command prompt. Both input and outputs are character based. So whatever the input I'm going to provide, that is in the form of character, and whatever the output I'm going to get, that is in the form of character. For that reason, it is also called character user interface. Then I'm going to have GUI. So what is GUI? That is nothing but the graphical user interface. So here I'm going to get the very beautiful working environment. So here users are not bothered about the commands. The GUI was first introduced in the year 1984 by Apple with Macintosh. GUI is an interface where the commands are selected from menus. Instead of typing the commands manually, what we are going to do here? We are going to select the commands. To select the commands, I'm going to have the menus as well as icons. So I'm going to have the list of menus as well as icons. In that, I'm going to select the commands. And how I'm going to select the commands? Through the mouse or from the keyboard. It allows user to click on the required icon. That means, suppose if I want to select any particular command, then what I will do, I'm going to use mouse and I'm going to click that particular command. Windows operating system is the most popular graphical user interface. The best example for GUI is Windows operating system. So this Windows operating system provides beautiful working environment to the user. Moving further, let's see the difference between CUI and GUI. So what is CUI? That is nothing but command line or character based user interface. Then what about GUI? That is graphical user interface. So here we are going to get very beautiful, attractive working environment. In under CUI, the user want to remember the command and they want to type the command. But under GUI, user want to know how to use the mouse. So the user must click on icons, menus, dialog box, etc. to interact with the computer. If I consider command user interface, suppose user want to interact with the computer, then the user is going to type the commands manually. But if I consider GUI, suppose user want to interact with the computer system, they are going to click the icons or menus or dialog box. The next difference under CUI is the user must remember the commands and their parameter. Suppose user want to interact with the computer system under CUI, then user want to remember the commands as well as the parameters. But if I consider GUI, the user need not remember any commands. So here users are not bothered about the commands as well as parameters, and it is available in the form of menus, icons on monitor, and mouse operations are not available for DOS. If I consider command user interface, then users are not able to use the mouse. The next difference under graphical user interface is if the user want to interact with the computer system, they are going to use the mouse. That means mouse operations required to select the commands. But if I consider CUI, then here we are not going to use any mouse operation. That means manually users are going to type the command. To type the command, they must want to remember the commands as well as parameters. And these are the some of the difference between CUI as well as GUI. And from the examination point of view, these two topics are very, very important. So dear student, in this chapter, we started with what is software, the type of software, along with that, what is linker, what is loader, what is assembler, what is compiler, what is interpreter. Along with that, we discussed what is an operating system, functions of operating system, features of operating system, along with that types of operating system. Dear student, I think that you got complete information about computer software. Thank you for watching my session. Let's meet in the next session. Until then, keep watching and keep learning. Thank you.